Good evening. In this video we'll be discussing section 3.4, elements and compounds. We're going to be discussing the vocabulary words element, periodic table, and compound. The last three I've decided that we will discuss in class, just to make sure they can be pretty complicated ideas, and I think it's just we're better served where I can discuss these ideas one-on-one with you in class, where we can work out some practice problems. So question number one, the objectives that we'll be covering in this video are distinguishing between elements. We want to distinguish between elements and compounds and describe the organization of elements in the periodic table. And this third objective, main objective for this section, we'll be discussing in class one-on-one. All right, so let's go to that first question. Distinguish between an element and a compound. Okay, so let's first describe what an element is. Okay. So I'm going to get a little bit, maybe not philosophical, but hopefully not too wordy here. But essentially, an element, everything that is anything in the universe, which is pretty much everything that exists, is made out of something. So everything is made out of something. And as it turns out, that something that everything is made out of is actually very specific. Okay, so let me tell you what I'm talking about here. So let's take a house, for example. A house is made out of pretty large structures called walls, doors, windows, and a roof, etc. So when you take a closer look at these large structures, you find that they're actually made out of smaller parts. Like, for example, the wall, it's made out of bricks, many bricks and cement put together. And you look at the windows, you take a closer look, and you see that they're made out of many window panes and frames. And then the roof. The roof is made out of roof paneling. Okay, so we find out that these building materials put together make up the overall finished structure that we recognize as a house. So similarly with the universe, okay, the universe is made out of very specific building material. These building materials, these building blocks of all of the matter are called elements. Okay. So just to kind of get a brief history on what this idea is, we used to think back in Aristotle's and Socrates' day, we used to believe that everything that we knew of, that we could see and feel and touch, was made out of four basic elements. We had earth, fire, water, and wind, and various combinations of these four elements made up everything that we see. But of course, we have a much more sophisticated way of looking at things now. We actually know now that everything that we see, including everything in the universe, is made out of one of 118 known elements. And now they might be combined differently to make different material, but so far as we know, including the universe that's out there in space, everything that we have in our periodic table is what constitutes the building blocks of all known matter. Okay, and it is enshrined here in our periodic table, which we'll be discussing today. 92 of these elements occur naturally on Earth. So we find most of these on planet. In fact, we pretty much find all of them on planet Earth. Even the ones that do not occur naturally, these other elements are either synthesized in a laboratory, or they're just too radioactive and exist only for a fraction of a second. So they don't have any real practical use for us, but it's still fun to try and make. So the universe as we know it is made up of these known elements. Okay. Now the fourth thing to understand here about the periodic table is that all elements are located in the periodic table. Okay. So I have here, I'm pointing at one particular element that we're going to highlight as an example. Okay, so this element is helium. Okay, so so you'll know how to read a periodic table or a basic element symbol. The periodic table, you're going to have three basic pieces of information. You're going to have your atomic number. Okay, you're going to have your element symbol, which has a capital. The first letter is capitalized, and if there's a second, it's going to be lowercase. And then the number right below that element symbol, you're going to have the the atomic mass number. Okay. So the periodic table. The periodic table. Let's first discuss our family groups. Okay. So I have an arrow here pointing down at the first group. Group number 1, I have group number 2. Now each of these groups has specific names which we'll address in a later lecture. And then I have group number 3, and then group number 4 through 12, I have an arrow there pointing towards where it begins and ends. And then we pick up with group 13, 14 and 15, 16, 17, and then 18. So the periodic table is broken up in two main ways. The first one we've just discussed, which is the groups. Okay, and there are 18 vertical columns called groups. Okay, now the other way that it's broken up is in periods. Periods are they go down. There's 7 total periods, and they actually go horizontal. I should backtrack. The groups are vertical columns, and then the periods are horizontal periods. So I have period number 1, horizontal period number 1, which extends all the way from hydrogen, and it skips all the way to number 2, helium. Okay, and then period number 2, I go from lithium all the way down to neon, and then groups 3 and 4, 5, 6, and then finally period horizontal period number 7. So I have 18 family groups that are vertical, and then I have 7 horizontal periods. Okay, the lanthanoids and actinoids that you see there at the bottom, we'll discuss those in greater detail as well in a later lecture. Okay, so this is 3.4, elements and compounds. We just basically discussed, or we're discussing and distinguishing between elements and compounds, and we just discussed what an element is. It's a single single entity. Now compounds are a combination of these entities. Okay, so as an example here, what you see here is actually a lab demo that we will perform in class with electrolysis. It's called electrolysis of water. Basically what that is that you see a fluid inside of these test tubes, which is just plain old water, pure water. There isn't any kind of solutes in it, so it's a pure liquid. Now in that water we run an electrical current through that using just a plain old 9-volt battery. And an interesting phenomenon occurs that once we run a current through that water, which its chemical name is H2O, meaning there are 2 hydrogens and 1 oxygen. What happens when that current runs through water is that we actually end up separating H2O into its constituent atoms or elements, which is hydrogen and oxygen. You'll notice that the amount of hydrogen is roughly double that of oxygen, because if you look at the formula for water, it's H2. There's 2 for every 1 oxygen there are 2 hydrogens, so it stands to reason and makes sense that when you're producing the gas, you're going to end up with double the volume of hydrogen gas than you do of oxygen. So H2O is considered a compound, and its constituent parts are its elements, hydrogen and oxygen, in the gas form. Okay, so looking at water, the compound. Compounds, as you can see, can be broken down into its constituent elements, whereas elements, pure elements, cannot be broken down further any more than they already have. It's like your house. Going back to our house analogy, when you take the house apart into its bricks, you could technically break the bricks up even more, but there's no real purpose to that. But in future lectures, we'll actually see that your elements can technically be broken down more, but for our purposes here, let's just say for now that you cannot break an element down any further than it already is at that point.